Hello and welcome to the seventh and final section of the Mastering Keras course. In this section we're going to look at one-shot learning and deep semi-supervised learning. Now both of these areas are very interesting. We'll discuss what they are before looking at particular deep learning implementations of them. In this video we're going to be talking about one-shot learning. So we'll discuss what one-shot learning is and why it would be significant. Now there's not going to be any code component to this video, but in the next video we will in fact be looking at how to implement a very interesting and what appears to be very positive method for performing deep one-shot learning called Siamese networks. So what is one-shot learning? Well, it's the ability to generalize from single instances. And if we take a classification case for its simplicity, it's the ability to recognize new instances of a class after exposure to a single instance of that class. Now, one-shot learning is very interesting conceptually because it's something that humans appear to be able to do. If not quite one-shot learning, then few-shot learning, which we'll talk about next, but let's keep it simple for now. Humans appear to be able to generalize from either a single or very few experiences, rather than needing large amounts of experiences before they're able to generalize and, in the classification case, be able to recognize instances of the class that they were trained on. So related to one-shot learning is this few-shot learning. And of course, the only difference here is that the generalization is able to occur after exposure to a few instances rather than specifically one. Now, why is one-shot learning interesting? Why is it potentially very important? Well, we face the problem that the world is varied and data is expensive. What do I mean by this rather simple claim? Well, it means that data over all potential variations can be hard to obtain. Now, in many cases, data is hard to obtain full stop. And so we only ever get to work with a very small amount of data, in which case being able to generalize from very little data will be very important. But even in situations where data is in general easy to obtain, we can face situations where the problem includes, for example, rare classes that are of particular interest but difficult to obtain training data for. And this occurs a lot. We're often interested in, for example, positive cases that are exceptional. When you're looking for faults in industrial systems, for example, most industrial systems are highly engineered and don't break down very often. They'll be fitted up with sensor systems. We'll have years or decades of data, so we'll have huge amounts of data, but we'll have very few instances of positive cases or fault cases. I worked with a project where we were trying to identify the health and numbers of rare fish species. And it's possible to get a lot of data on fish in the area that we were working on. So we were looking with image data. There was lots of images of fish, but of course, rare species had very few images in the historical data set. But those were the ones we really wanted to be able to identify in the future when we were applying these systems. Now, there's also the issue that, in essence, the number of classes of our problem is essentially unbounded. The problem might contain so many classes. No matter how many classes we have in our training data, new ones will occur in the wild. And we're going to have to be constantly capable of identifying new classes that we haven't seen previously. Now, of course, the first time they occur, we can't hope to identify them. Well, it will be very difficult. One-shot learning won't help with that. But the fact that one-shot learning would permit us to immediately be able to identify new cases of a novel class subsequent to its first appearance. But moreover, even if data can be obtained, data can be very expensive to obtain in terms of time or in terms of money. And if you think about images and text data, for example, labeling these things is extremely expensive in terms of time and money. But a lot of statistical machine learning requires a lot of data and labeled data if we're working with supervised learning techniques. So one-shot learning might be able to mitigate these problems, as well as being simply interesting for trying to work out how to make artificial intelligence systems such as statistical machine learning systems closer or resemble more human reasoning processes. Now, this problem of having to work with a lot of data and the fact that this might be difficult to obtain, and if it can be obtained, it might be expensive to be obtained, it's particularly problematic when it comes to deep learning. Deep learning is particularly associated with the use of large amounts of data. And so in some ways you might be surprised to think of even the possibility of one-shot deep learning. Nonetheless, we're going to see that one-shot deep learning is possible, and one promising deep learning approach is known as Siamese networks, which we'll look at in the next video. What these are going to do is build a similarity detector in the form of a binary classifier, which gives the probabilities that two instances are of the same class, irrespective of class. And what that means is that a single instance of a new class can then be used to check whether new data are of that class. So once we have a similarity detector for the problem in general, it will give us the probability that any two instances are of the same class regardless of what that class is. At that point, we have what looks like a good one-shot learning system, because any new class, we can now use that as a prototype to check of any other datum whether or not it is of the same class as this one.